Hello, welcome to RR Max channel. We are doing reduction formulae. We will do problems related to tan, cot, secant and cosecant today. So we start with evaluate the following integrals. I take the first one, integral tan to the power of 4x dx. We have found the formula as In is equal to tan to the power of n minus 1x divided by n minus 1 minus I n minus 2, and I naught is equal to x for this. Now I4 is integral tan to the power of 4x dx. Now by using the formula n is 4, so when I substitute n minus 1 becomes 3, n minus 2 becomes 2. So you have tan cube x by 3 minus I2. You do it again for I2. So I2 is equal to n is 2 now, so it reduces to tan x by 1 minus I naught. I naught is x. Go back and substitute for I2 in I4. So that gives I4 is equal to tan cube x by 3 minus of tan x by 1 minus x. That becomes plus x when you add the outside minus sign. So that is your final answer. Next problem, integral of tan power 6x dx. I call it as I6. We use the same formula, tan to the power of n minus 1x by n minus 1 minus I n minus 2. So I6 is equal to tan to the power of 5x by 5 minus I4. I4 is equal to tan cube x by 3 minus I2. I2 is equal to tan x minus I naught. I naught is x. So I come back here, I substitute I naught as x, and here I substitute the I2, and the whole thing I substitute I4. Finally my I6 reduces to tan to the power of 5x by 5 minus tan cube x by 3 plus tan x by 1 minus x. That is going to be your final answer. We shall see the next problem. Evaluate integral 0 to pi by 4 tan to the power of 5 x dx. This time we have limits. I am using the same formula, In is equal to tan to the power of n minus 1 x divided by n minus 1 minus I n minus 2. But I will substitute the limits 0 to pi by 4. So I call this integral as I5, and so for I5 you get a formula as tan to the power of 4x by 4, limits varying from 0 to pi by 4 minus I3. So when you substitute your limits here, tan pi by 4, that is tan 45, value is 1. So you will get 1 by 4 here. And when you substitute 0 for the lower limit, tan 0 will be 0. So lower limit will not exist. Now I3, when you substitute, you get tan square x by 2, limits varying from 0 to pi by 4 minus I1. Again tan square x, you substitute upper limit 45. So tan 45 is 1, so you get half, and lower limit will be 0. Now I1 gives us an answer as log secant x, limits varying from 0 to pi by 4. Now log of secant of 45, secant 45 is going to be root 2. So your value for I1 is going to be log root 2 minus log of secant 0. Secant 0 value is 1, log 1. But value for log 1 is 0, and therefore I1 reduces to log root 2. You go back and substitute for I3, you get half minus log root 2, and I5 becomes 1 by 4 minus half plus log root 2. 1 by 4 minus half reduces to minus 1 by 4. So it is log root 2 minus 1 by 4. Now log root 2 can be written as log of 2 to the power of half. So half comes down, giving it as half log 2. And so for both the cases, I can take out half as common factor, leaving you an answer with half into log 2 minus 1 by 2. Sorry, this should be 2. We come to the next problem. I3, I call this as I3, integral of cot cube x dx, using the formula directly for cot cube. So In is equal to minus cot to the power of n minus 1 x by n minus 1 minus I n minus 2, n is 3 here. So I3 is minus cot square x by 2 minus I1. I1 is log sin x. Go back and substitute. So you get your I3 as minus cot square x by 2 minus log sin x. Next problem, I take integral of cot to the power of 4x dx. I call it as I4. Now n is 4, you substitute. So I get I4 is equal to minus cot cube x by 3 minus I2. And I2 is minus cot x by 1 minus I0. I0 is x. Go back and do the substitution. You get I4 is equal to minus cot cube x by 3 plus cot x plus x. Next I go for secant. So evaluate integral secant to the power of 4x dx. I call it as I4. Formula for secant, that is In is equal to integral of secant power n x dx is 1 by n minus 1 secant to the power of n minus 2x tan x plus n minus 2 by n minus 1 into I n minus 2. Now in this case n is 4. So you substitute I4 is equal to 1 by 3 secant square x tan x, that is here, plus 2 by 3 I2. Now you go back to I2, n is 2 now. So you get 1 by 2 minus 1, which is 1. And here secant to the power of 2 minus 2, which is 0. So secant past 0x will be 1 into tan x plus this term will not exist here because we don't have that n minus 2 in the numerator will become 0 here. So this just reduces to tan x. So your formula here I4 is 1 by 3 secant square x tan x plus 2 by 3 tan x. You can leave your answer in this stage if it is just 2 marks or something. But if it is 3 marks or 5 marks, or if they say prove that, you have to convert it completely in terms of tan. So this secant square x I have replaced as 1 plus tan square x. So you get 1 by 3 into 1 plus tan square x tan x plus 2 by 3 tan x. Here you have 2 tan x terms, so you can club that. So that gives you 1 by 3, this is a tan cube x plus 1 by 3 plus 2 by 3 is 3 by 3, which is 1. So into tan x. So your answer is 1 by 3 tan cube x plus tan x. Now I'll see a problem with the limits. Evaluate integral 0 to pi by 4 secant to the power of 5 x dx. I call it as I5. I use the same formula, but I'll substitute the limits in between. So you get 1 by 4 secant cube x tan x, limit varying from 0 to pi by 4 plus 3 by 4 I3. Now when you substitute pi by 4, secant pi by 4, that means secant 45 is going to be root 2. And when you say root 2 whole cube will come, and tan 45 is going to be 1. And for 0, lower limit tan 0 is 0, so lower limit will not exist. So upper limit here will be root 2 whole cube into 1. So that is 2 root 2 into 1 divided by 4. Plus 3 by 4, I3 is there. So I3 you write your formula, you get half secant x tan x, limits varying from 0 to pi by 4 plus half into I1. Again you substitute your limits here. Secant x will become root 2, tan 45 will become 1, secant 45 is root 2, lower limit 0, it is 0. Now you go for I1. I1 value is log of secant x plus tan x, limits varying from 0 to pi by 4. So when you substitute upper limit, you get log of root 2 plus 1 and lower limit is going to be log 1 and log 1 is going to be 0. So now you go back and substitute everything here to get I5 as 1 by 4 root 2 whole cube minus 0 lower limit plus 3 by 8 into root 2 minus 0 plus 3 by 8 into log of 1 plus root 2 minus log 1 is 0. So we will club here and to get an answer as 2 root 2 by 4 plus 3 by 8 root 2 plus 3 by 8 log of 1 plus 2 root 2. Now this 2 you can club, so this is 2 by 4 plus 3 by 8. You just multiply this numerator and denominator by 2, so you get 4 by 8 here. So 4 plus 3 is going to be 7 by 8. So this 2 reduces to 7 by 8 root 2 plus 3 by 8 log of 1 plus root 2. Next problem, evaluate integral of cosecant to the power of 6x dx. I call it as I6 and your formula here In is minus of 1 by n minus 1 cosecant n minus 2x cot x plus n minus 2 by n minus 1 into I n minus 2. So we'll apply the formula here, and that gives I6 as minus 1 by 5 cosecant to the power of 4x cot x plus 4 by 5 I4. And I4 will be minus 1 by 3 cosecant square x cot x plus 2 by 3 I2. I2 will be minus cot x plus you won't have the term, that is n minus 2 will become 0. So go back and substitute, you get your I4 and then you get your I6. So your I6 here is minus 1 by 5 cosecant power 4x cot x plus 4 by 5 into minus 1 by 3 cosecant square x cot x minus 2 by 3 cot x. As usual, if it's just 2 marks, you leave it here. If it is more than 2 marks, you try to simplify this. You can replace cosecant square x as 1 plus cot square x, simplify all the expansions and collect the terms, and that gives you your final answer here as minus cot x minus 2 by 3 cot cube x minus 1 by 5 cot to the power of 5x, where I have taken out minus cot x as a common factor into 1 plus 2 by 3 cot square x plus cot to the power of 4x by 5 will be your final answer. Now we will see another problem. Evaluate integral of secant x tan square x dx. Now this I don't have a direct formula here. So what I do is for tan square x I replace it as secant square minus 1. So it becomes integral of secant x into secant square x minus 1 into dx. You have it as 2 integral of secant cube x dx minus integral of secant x dx. Now secant cube, you apply a formula, you get half secant x tan x plus half log of secant x plus tan x, and integral of secant x will give you minus log of secant x plus tan x. So this is plus half and this is minus 1. So if you simplify, you get minus half. So it is half of secant x tan x minus half of log secant x plus tan x. So next I will try to take, these are the models that you have for your tan, cot, secant, cosecant, etc. Now we will see some proof type of problems. So the question here is, if in is equal to integral of 0 to a x power n e power minus x dx, prove that in minus n plus a in minus 1 plus a into n minus 1 in minus 2 is equal to 0. Now I have used in. So in the question paper, if they use in, you use in. If they use some other symbol here, then you are supposed to stick on to that particular symbol only. So here in is equal to integral 0 to a x power n e power minus x dx. We will use integration by parts, where I assume u is equal to x to the power of n. So du is equal to n into x power n minus 1 dx. dv is equal to e power minus x dx. So when you integrate, you get v is equal to e power minus x by minus 1. So now you substitute integration by parts, which is uv minus integral v du. You get it as x to the power of n e power minus x by minus 1, limits varying from 0 to a, minus of integral 0 to a e power minus x by minus 1 into n x to the power of n minus 1 dx. So now when I substitute a for x, I get minus a power n e to the power of minus a. Lower limit x is there, so when you substitute x as 0, it becomes 0. Plus, because there is a negative sign here and negative sign here, making it positive. N comes out, integral 0 to a, you have x power n minus 1 e power minus x dx. So this now reduces to minus a power n e power minus a plus n into I n minus 1. So we just look in our formula, we have I n minus 2 there. So now I write here I n is equal to minus a power n e power minus a plus n into I n minus 1. You call this as 1. And now you substitute n is equal to n minus 1 in this formula. So instead of n, I am going to put n minus 1. I get I n minus 1 is equal to minus a to the power of n minus 1 e power minus a plus n, instead of n I am using n minus 1, I have n minus 1 I It is already n minus 1. So instead of n, you are putting n minus 1, which will reduce to I n minus 2. Now here you multiply throughout by a. So that gives you a times I n minus 1 is equal to minus a power n e power minus a plus a into n minus 1 I n minus 2. Call this as the second equation. Now, in my answer, I do not have this a power n into e power minus a term, and therefore I am trying to cancel that term, and that is why I multiplied the second one with an a. So now you just subtract the first and the second equation. You get in minus a times in minus 1. These two terms get cancelled, and here you get plus n into in minus 1 minus of a times n minus 1 into in minus 2. Now you bring that everything to one side. So you get this as in minus n plus a into in minus 1 plus a into n minus 1 into in minus 2 equal to 0. This is what they have asked. So this is how you try to derive a reduction formula or prove whatever they want you to prove. We'll stop here. If you like my videos, please like, share to other students and subscribe my channel. Thank you. Meet you in the next episode.